Hello, everybody. My name is Kane and welcome to my project on lofting, estimating mineral distribution with convolutional GAN models. My graduate advisor, Hoon Seo, advised by Dr. Hua Wang at the Department of Computer Science, Colorado School of Mines. Now, estimating geographic mineral distribution is an important task in mine location planning. In essence, mine planners have to figure out where to place a mine to get the most amount of results. And to do so, they usually drill small little boreholes in the ground. And so there are these really thin lines you can imagine in a big cube of terrain. That's very sparse data. And generally, this data is pretty inaccurate. The borehole results can often be misleading, and on one extreme, a seemingly promising location could be a complete flop, and on the other, a seemingly boring complete location that got skipped over could be a dense trove of minerals. So the question lies, is there a way to improve these sparse borehole observations? Is there a way to improve the accuracy and potentially capture a more accurate snapshot of the mineral distributions just based on those blocks in the ground? Hoon and Dr. Wang have initially shown that it is possible to estimate these distributions using neural networks, specifically convolutional generative adversarial imputation networks, which are used to predict data from sparse amounts of data. In this model, the core of it is the imputation, which is the process of replacing missing data with predicted values. And to do this, the model follows a three-step process that takes all the way from raw mineral input data in tensors to a visualization of the predicted data in a three-dimensional space. The first step is mapping, which takes those set of boreholes into spherical coordinates and maps those to sparse tensors, which we can then use to impute the data from, because we get the sparse mineral data, what we observe, and we can then recover information. And then finally, once we've done that, we can visualize that data using a series of techniques, whether it be a 3D graph or a new technique that we've come up with called alpha shape coloring, which generates triangles between 3 points in space to show the average mineral distribution in a given spot. Once we've run data through the model, we can finally then use Plotly, the platform for data visualization, to generate these three-dimensional graphs that demonstrate the mineral distribution of any given mineral, whether it's gold, silver, copper, or platinum, or etc., in that block of terrain. And then we can additionally zoom in once we apply alpha shape coloring and observe these nice volumes that are surrounded by these surfaces generated by the average densities between points. And we are also looking at implementing new and unique hinting mechanisms that might improve our ability to impute new data. Thank you for attending our talk.